Hi guys, a very good evening everyone and welcome back to the GATE 2024 Rankers Monsoon course, and this is the EMFT going on currently with the common topics of electronics and electrical. And in this particular class we are going to discuss up the important questions on electric potential, because yesterday also I told you electric potential is an area where different varieties of question have been continuously being asked. Okay, so what can be the different variety, how to approach them, all that we are going to see in this particular class. Let's get moving ahead. Okay, okay, chalo. Okay, quickly update your friends, the session is live, and let's get started quickly. Quickly update your friends. All right, chalo. So this is a regular introduction about me. Let's go to the next. And yes guys, this Sunday, okay, 13th August, starting from 9 a.m. you get a chance, okay, to appear in National Scholarship Test, and wherein you can get up to 90% scholarships on the GATE preparation programs by BYJU'S exam prep and take a next step towards your success in GATE. Register now on the app and appear in the exam on Sunday and get, prove yourself and get huge scholarships. Also guys, the coming Wednesday, the Wednesday 16th August at 7:30 p.m. all your favorite Richa madam is going to come up and give you useful 5 tips to get triumph in GATE 2024. Okay, that is to be very, very successful in GATE 2024. What are those important 5 steps? Okay, so join live Wednesday again on the BYJU'S exam prep app. Here it is, the first question for the day. Let's start with the simple and the potential due to point charge case. Find the potential at 1 minus 2 4 due to a 2 nanocoulomb charge which is located at the point 3, 0, 2. At the point 3, 0, 2. Okay, now what is the potential due to point charge? What is the potential at any point due to point charge? And since potential is a scalar quantity, so we don't have that vector calculations like yesterday we were doing for the electric field. So suppose this is your source charge Q, and that is placed at some point. Okay, that is placed at some point which is 3, 0, 2. Suppose that is the point A. Okay, where there is a charge of 2 nanocoulomb placed, and that is what is a source charge, and you are required to calculate the potential, okay, at some point P which is 1, minus 2, 4. So as always I will call it as my source. Okay, this is the source due to which I would like to calculate the potential at the point P, which I am going to call it as point of observation. This is the point of observation where the potential is required. In short, I will keep calling it as POI. Okay, now what is the potential at this point? First of all, we'll be measuring this particular distance that is known as R. Here we don't need the vector because potential, as I told you, is a scalar quantity. We only need the distance, that is the AP. Okay, so what is this distance equal to? Okay, that is the distance AP, and that is equal to, the coordinates of both the points. So distance formula you can apply, and what is the distance formula? Root over of x2 minus x1, that is 1 minus 3 whole square, y2 minus y1, minus 2 minus 0 whole square, plus z2 minus z1, that is 4 minus 2 whole square, and the distance, eventually this is 2 square 4, again 2 square 4, again 2 square 4, so root over of 12, or you can call it as 2 root 3. Okay, we can call it as 2 root 3. So distance is equal to 2 root 3. The distance is just equal to 2 root 3, right? Okay. Now, what is the potential at this point? Okay, what is the potential at any point due to a point charge is given by the formula KQ by R. Okay, so since this is a question based session, so we'll revise of course all important formulas with the help of question, or we can also write it as Q upon 4 pi epsilon naught R. Okay, K is 1 upon 4 pi epsilon naught. Okay, nothing is mentioned, so of course it is free space, that is why I have taken epsilon naught, and then the potential at this point becomes, what is K? In free space, K is 9 into 10 power 9 multiplied by the source charge due to which we are calculating the potential, 2 into 10 power minus 9 divided by the distance which has turned out to be 2 root 3. Okay, and this should be the answer. This much volt should be the answer. 10 power 9 and minus 9 cancel. Okay, 2 and 2 cancel. 9 by root 3, and that is nothing but 3 root 3. 3 root 3 volts is the answer. Okay, or if I calculate its value, 5.196, or let me put it as approximately 5.2 volts is my answer. Right? Good evening, dreamer. So my final answer stands out to be 5.2 volt. My final answer is 5.2 volts. ठीक है. Okay. Next, what is the value of work required, okay, to move a 8 nanocoulomb charge from infinity to a point P, which is at a 2 meter distance, okay, from a point charge. Now see, we know that how potential is actually defined. So when we want to talk about potential difference between any 2 points, the previous one was absolute potential, but suppose I want to calculate potential difference between any 2 points, okay, which is also VB minus VA, and the potential difference between any 2 points is given by the formula. Okay, is given by the formula. There are 2 ways. Number 1, it is given by the line integral of the electric field. It is given by integral, negative of integral E dot dl from the point A to the point B. Okay, but the basic formula can also be used as potential difference between 2 points is equal to the work done to move a charge Q, the work done to move a charge Q from point A to point B divided by the value of the charge. That means work done per unit charge. Work done per unit charge in moving that charge from point A to point B. Okay, and that work done per unit charge is known as the potential difference between the 2 points. Now, what is the work done in moving a charge from infinity to some point P? Okay, from infinity to some point P. So if I take one of the point as infinity, okay, the work done from infinity towards some point P divided by the value of the charge, okay, that is V infinity P, and that is what is Vp minus V infinity. V infinity as reference, we know it's 0. So that is what is the absolute potential, what we calculated in the last. Okay, so what is the absolute potential? Okay, that is V infinity P divided by charge. So the absolute potential of any point, is equal to the amount of work done in moving that charge from infinity towards the point P divided by the value of the charge. That means again work done per unit charge. Okay, now in the next question what they are asking is, what is the value of work required to move a 8 nanocoulomb charge from infinity to point P? That means work done from infinity to the point P, and that is nothing but Q into, work done is Q into V. Okay, Q into V infinity P, but as I told you, V infinity P is just Vp because potential at infinity is 0. Okay, what we need to calculate is QVP. Okay, what is the value of the work required to move what charge? 8 nanocoulomb charge. Okay, so what is this Q? This Q is 8 nanocoulomb. Okay, from infinity to a point P. So what is the potential at the point P, which is at a 2 meter distance from a point charge? Okay, so there is a source charge. Which is 5 microcoulomb. Okay, and there is the point P. Which is at the 2 meter distance. Clearly here, why it is simple is because the distance is directly mentioned. Okay, distance is directly mentioned. So there is a 2 meter distance. There is some point P. What is the potential at the point P? What is the potential at this point P? The potential again will be using the formula KQ by R. Which Q? It is going to be 5. Okay, it is going to be this source charge, that is the 5 microcoulomb. So it is 9 into 10 raised to the power 9 into 5 microcoulomb. Okay, so 5 microcoulomb is 5 into 10 power minus 6 divided by the distance which is directly given. Okay, so this is equal to 45 by 2, 22.5 into 10 raised to the power 3 volts. Now what is the work done then? So now we have got the answer. Work done is equal to QVP, and the Q here will be 8 nanocoulomb. That is 8 into 10 power minus 9 multiplied by the value obtained, that is 22.5 into 10 raised to the power 3. So that's going to be definitely in microjoules. 10 power minus 6 micro के form में आ गया, and this one is clearly 180 microjoules. The answer 180 microjoules. The final answer 180 microjoules. That is the option number A. 180 microjoules, that is the option number A is the very correct answer. Why is this not moving? So you have done masters, and are you looking again for the preparation of GATE exam, Akbar? Right? Chalo. Is that what I am able to understand from your comment? है ना? So that I can tell you accordingly. So 180 microjoules is the answer. Moving ahead to the next one. Okay. Now, electric field is given to you. If the electric field intensity is given by xux plus yuy plus zuz, what is the potential difference between the points x and y? Okay, that means the question is asking you vx minus vy, which can be written as vyx. As I told you, VAB is VB minus VA. Okay, VB minus VA. Okay, VB minus VA. So Vx minus Vy will be Vyx. Okay, we write down final minus initial. Okay, so Vyx. Now what is Vyx? It is negative of the integral E dot dl. Okay, negative of the integral E dot dl from the point y to the point x. From the point y to the point x. Okay, so that is what we have to just calculate. So let's start calculating. Vx minus Vy is negative of the integral y to x, and what is the y point? चलो वो बाद में रख देंगे. Okay, let me first substitute the electric field, which is xux, right? Yeah, xax, you know, whatever you can call it as. Xax plus yay plus zz, dot product with dl, and Cartesian coordinate system. What is the dl? The differential length is dxax plus dyay plus dzaz. Okay, right? So on solving, what we are going to get is, when you take the dot product, okay, you are left with x dx, y with dy, z with dz. All are separate, x with dx, y with dy, z with dz, and eventually your integral is now x ka integral x square by 2, y integral y square by 2, z dz is z square by 2. So overall x square plus y square plus z square whole divided by 2. The lower limit y, now I can put down the point. The y is 1, 2, 3, and the upper limit x is 2, 0, 0. Okay, and then this is equal to minus of, put down the upper limit. Okay, so upper limit will be 2 square by 2 minus lower limit 1 square plus 2 square plus 3 square divided by 2. Okay, so get this 2 square cancelled. 9 plus 1, 10, 10 by 2, 5, minus minus cancel. Answer will be plus 5 eventually. Plus 5 volts. The potential difference between the 2 points is the plus 5 volt, option number C. The plus 5 volt, that is the option number C. Okay. So Akbar, I would basically suggest you first focus on your non-core areas. Like, you may be good in electrical, okay, but focus on areas like EDC, analog communication, and EMFT, the extra EMFT portion. These 3-4 are going to be very crucial, okay, if you are going for EC gate preparation. Okay. Chalo, let's move ahead to the next one. Okay, now we know that, okay, this is the formula already I told you. Potential difference can be calculated as line integral E dot dl minus of integral E dot dl. Okay, now look into the next variety of question. Okay, chalo pehle simple wale pe aate hain, forget this. Let's come to this question. Given the potential, and then we'll go back to that. What is the electric field? Okay, what is the electric field? Now, as I already told you, potential difference is the line integral of electric field. And what is the relation between electric field and potential? Well, very, very important formula. It is negative of the gradient of V. Very, very important formula. How to obtain the electric field is negative of the gradient of V. First, let me start with Cartesian question. But from this area, question can be from spherical coordinate system, cylindrical coordinate system. It can be from anywhere. Okay. It could be from anywhere. Okay. So E is negative of the gradient of V. Okay, negative of the gradient of V, right? What is the V? V is given to you as 60x square yz, 60x square yz, okay, plus 15y square. Okay, and electric field is going to be negative of the gradient of V. Okay, this is an important formula. Many questions have been asked in previous years as well. So this becomes negative of gradient V formula in Cartesian coordinate, del V by del x Ax plus del v by del y ay plus del v by del z az. Del v by del x ax plus del v by del y ay plus del v by del z az. Okay, now we just have to put down the derivative and then at some point p wo baad mein rakhte hain, but first what is the general expression for the electric field in this region? Negative of del v by del x, differentiation with x square ka derivative 2x, so 120 x y z ax, differentiation with y तो 60 x square z ये भी आएगा 60 x square z, and this also will be differentiated with y, so that will be 2y, so 15 2s are 30 y ay, and del v by del z, differentiation with z, okay, 60 x square y az. Now what we need the answer at the point, right, at the point, and that to intensity, मतलब magnitude चाहिए, right, at the point p 1, 2, 3, इसको next slide पे ले लेते हैं, okay, at the point p 1, 2, 3, so at the point p which is 1, 2, 3, there the electric field will become minus of, okay, 120 xyz to 120 into 1 into 2 into 3 ax plus 60 x square z, 60 x square z plus 30 y ay plus z component which is 60 x square y az. Okay, so electric field here is equal to negative of ये हो गया 6 to 720 ax plus 180 plus 60 240 ay plus 62s are 120 az. Okay, electric field is, if I take 120 common, okay, so minus 120 6ax plus 2ay plus az. Now if they're only asking the magnitude, the strength of this field, the intensity of this field, so it is 120 under root of 6 square plus 2 square plus 1 square, and let me calculate and give you this number finally. Okay, that is going to be 768.37 768.37 volts per meter. 768.37 volts per meter. Okay, so here we have the option number B, which is correct. 768.37 volt per meter, option number B is perfectly correct. 768.37 option number B. Done है जी? Okay. ठीक है. Now a similar question. Okay, a similar question again, very important. This was in Cartesian coordinates. Okay, but now given the potential, okay, 10 by r square sine theta cos phi. So the function this time is given to you in the spherical coordinates. Given the function in the spherical coordinates, find the electric flux density at the point 2 comma pi by 2 comma 0. Electric flux density at the point 2 comma pi by 2 comma 0. Now we all know that what is the electric flux density? D is related with E as epsilon E, right? D is epsilon E. Okay, and what is E? That is again the previous formula I told you, negative of the gradient of V. Negative of the gradient of V. Okay, and this time the V is in the spherical coordinates. What is that V? It is 10 by r square sine theta cos phi. Yeah, 10 by r square sine of theta cos of phi. So what is the gradient of V in the spherical coordinate system? Formula is del V by del r ar, right, plus 1 by r del V by del theta a theta plus 1 by r sine theta del V by del phi a phi. This is what is the gradient of V. Okay, Now let's calculate this derivative. Differentiation with what? 1 upon r square derivative minus 2 by r cube. So this becomes minus 20 by r cube sin theta cos phi ar plus 1 by r del v by del theta. Differentiation sin theta will be cos theta. Okay, so 1 by r into 10 by r square cos theta cos phi plus 1 by r sin theta plus 1 by r sin theta. Differentiation with phi, cos phi derivative will be minus sin phi. So minus 10 by r square sin theta sin phi a phi. Okay. This is what is the general formula. Now we need this at the point 2 comma pi by 2 comma 0, right? So directly let us put the point at 2 comma pi by 2 comma 0. Now what you have to pay attention is, okay, theta is pi by 2 and the phi is equal to 0. Theta is pi by 2, phi is equal to 0, right? Sin theta 1. Okay, sin pi by 2 1, cos 0 is 1. Okay, so first term आ जाएगा minus 20 by r cube, r is 2, so 20 r cube is 8. Okay, ar, but cos theta, now theta is pi by 2. Okay, cos theta will be 0. In the next term I have sin phi, and because phi is 0, sin phi will be 0. That is why the next two terms are not required. The next two terms are not required. Okay, next two is just 0 and 0. So I have this minus of 20 by 8 minus 2.5 ar. That is only the gradient. Okay, so we have obtained the gradient of V is minus 2.5 ar, and then we were asked with epsilon d, which is equal to epsilon e or epsilon naught e, because if it is a free space. Okay, so we'll put down the value epsilon naught 8.854 10 raised to the power minus 12, and the electric field is negative of the gradient of V, so minus 2.5 ar. Negative of the gradient, so negative positive actually. Okay, so plus 2.5 ar. Okay, so solving the value, okay, I am getting the flux density as equal to 22.135 ar, okay, into 10 raised to the power minus 12 actually. So यहाँ ठीक है, इसको ar ही बोल देते हैं, and 10 power minus 12 is picocoulomb per meter square is the flux density unit. So 22.135 picocoulomb per meter square in the radial direction, the ar direction. Okay, ठीक है, done है. Next question then. This was Cartesian, this was all even simple. Moving ahead to the next question, the electric field which is assumed to be in one dimension. So whenever there is a one-dimensional field, okay, whenever there is a one-dimensional field and they are asking the electrostatic potentials at the A and B is suppose phi A and phi B, what is the value of phi B minus phi A? It's like VB minus VA, or you can call it as phi AB. Okay, phi AB, or it is just like VAB. What you need to calculate is VAB, the potential difference between the points, okay, A and B. Okay, so I need to calculate phi B minus phi A, that is phi AB or VAB. Now we all know that. Okay, पहले इधर आ जाते हैं. What is VAB? It is negative of the integral E dot dl, and already we have taken questions on this point. It is negative of the integral E dot dl. Hi Jagdish. Okay. Now here electric field is in one dimension. Okay, whenever you have the electric field which is in one dimension, that means let us say it's only in x dimension, so it will have x component and in the ax direction. Okay, and if that is the case, oh, I'm sorry. If that is the case, dl can also be taken along the x direction only, so that VAB will now become negative of ax dot product with dx ax. So ax dot ax is 1, and eventually you have negative of ex dx, right, where ex will be a function of x, Okay, so what is this point representing? What is this point representing? This is simply telling you that, okay, for 1D field, it is negative of the simple integral of the electric field. Okay, and that means the integral is also equal to area under the curve. So it is negative of the area under the E curve. Simple. You can put it and conclude it this way. Okay, it is negative of the area under the E curve. Okay, and we can use this directly here. Okay, what is the VAB? It is the negative of the area under E curve. Whenever it is a one-dimensional field, we can directly use this area concept. Okay, now we need a potential difference between the points A and B. So what is the area under this is the E curve. Okay, this is a flat 0. Okay, the field here is 0 kilovolt per centimeter. This is 0. This is also 0. So we only need to calculate this much of the area. And what is that area? It is equal to negative of area of trapezium, we all know. Okay, area of trapezium we all know, half into distance between parallel sides. So that will become 20 plus 40. Okay, 20 plus 40. Okay, but that is in kilovolt per centimeter. Ye dhyan rakhna. Okay, 20 kilovolt per centimeter plus 40 kilovolt per centimeter. Okay, distance with sum of the parallel sides into distance between parallel sides, that is 5 micrometer. Okay, so this turns out to be minus of 1 by 2 into 60 kilovolt. So 60 10 power 3 upon centimeter 10 power minus 2 into 5 micrometer, that is 10 power minus 6, everything converted to the standard units. Okay, and then I am left with, what is that answer? 300 by 2, 150. Okay, minus of 150 into 10 power, ye ho gaya 5 and minus 6, so only 10 power minus 1. So the final answer is minus 15 volts. Minus 15 volts. Done hai? So for 1D fields, you can calculate the potential difference by the concept of area. Okay, and the answer, it was a numerical type question. The area in the value of 5B minus 5A in volts is minus 15. Is equal to what? Is equal to the minus 15. Done hai? Chalo. It's clearly mentioned, dreamer, the electric field which is assumed to be one-dimensional. If it is not mentioned, then how to calculate potential difference? Like we have solved the question Vx minus Vy. That is line integral of the electric field. That line integral becomes a simple one-dimensional integral, and that is why we use the area concept if it is 1D. Otherwise, that you can refer to that Vx minus Vy question, dreamer. How we calculated there? Okay, and by the way, you are asking about E, so E will be mentioned. Okay, you can calculate VAB. Okay, VB minus VA. Or if V is given and they ask electric field, then negative of the gradient of V. Those questions also we discussed, right? Chalo. Next one. The potential distribution, the potential scalar distribution is given as 10y power 4 plus 20x cube. If epsilon naught is the permittivity of free space, what is the charge density at the point 2, 0? What is the charge density at the point 2, 0? What is the charge density at the point of 2, 0? At the point 2, 0. Let's look into this. Okay, now see, there is we can merge Gauss law and the relation between electric and electric field and electric potential, but there is a direct relation between the charge density and the potential, and that is given by del square V is equal to minus rho V by epsilon, and this is what is known as, this is what is referred to as the Poisson's equation. This is what is the Poisson's equation. Del square V is equal to minus rho V by square epsilon. So what is going to be the rho V? Here they are asking the charge density, rho ya rho V. So rho V can be written as minus epsilon del square V. Okay, now since is it free space? It is free space, the epsilon will be epsilon naught, and del square V minus epsilon del square V, Laplacian V in the Cartesian coordinate, del 2V by del x square plus del 2V by del y square plus del 2v by del z square. That is the Laplacian formula in the Cartesian coordinate. Okay, so what is the rho v is minus epsilon naught because free space hai. Okay, and then del 2v by del x square. What is the v given to me is 10y power 4 plus 20 x cube. Okay, differentiation, double derivative, it's only 2d, we don't need the derivative with z. Okay, but yeah, what is the double derivative with x? So, what is the first derivative? एक ही बार में करेंगे. What is the first derivative? 3x square. Again differentiate with x, so x square का derivative will be 2x. Double derivative with y. Okay, so first derivative 4y cube. Again y cube derivative 3y square. Okay, so that's it. What is the rho v? It is minus epsilon naught into 120x plus 120y square. 120x plus 120y square plus 120y square. Okay. Now we need this at the point 2 comma 0. At the point 2 comma 0, rho v is minus epsilon naught into 240 plus y की जगह 0. Okay, so it is minus 240 epsilon naught is the answer. Minus 240 epsilon naught, that is answer is D. Minus 240 epsilon naught, answer is D. Okay. So now, as I told you, del square v is minus rho v by epsilon, and if you have a charge-free region, del square v is minus rho v by epsilon, and if there is a source free or a charge free region, okay, for a source free or charge free region, rho v is 0. If there is no charge, there is no volume charge density, and then we get the equation del square v equal to 0, Laplacian of v equal to 0, and this is simply what you call it as? This is simply what you call it as the Laplace equation. This is simply what you call it as the Laplace equation. Del square v is equal to 0. The del square v is equal to the 0 is the Laplace equation. Okay. Now have a look into the next question. Okay. Two concentric, it's a good question, important one. Two concentric conducting spheres having the radii 3 and 5 are centered at the origin. The potential on the inner sphere is 100 volt, while the potential at the outer sphere is minus 100 volt. The medium between them is filled with a homogeneous dielectric having epsilon r equal to 2.2. Find the potential function and the value of r at which the potential is 0. Okay, find the potential function. अब देखना यहाँ पे, let's try to understand one point here is, there are two concentric conducting spheres. There are two concentric conducting spheres and they are concentric. Okay, right, having radii 3 and 5, having some radii that is known as 3 and 5, one is 3 centimeter, one is having the 5 centimeter. They are filled with a region having the relative permittivity is equal to 2. Okay. Now definitely the potential on the inner is 100, potential on the outer is minus 100. So what is the potential on this is equal to 100 volt. The potential on the outer is minus 100 volt. That means if I want to, looking into this picture, if I want to say V is the potential, and that is nothing but the potential which is a function of R. Okay. It is a function of distance because for two different radii, that is for two different values of R, you have the different potential. It's a function of R. Okay. And there is no source, that is there is no charge density given. So we'll be using the Laplace equation to solve it up. Okay, because it's the source free case. So let's start with the Laplace equation. And Laplace equation is del square v equal to 0, but v is a function of r, so spherical coordinate system, and since it is only a function of r, okay, since it is only a function of r, v which is only a function of r, okay, the Laplacian equation, the Laplacian will be equal to 1 by r square del by del r of r square del v by del r, and this is equal to 0. Del square v, that is 1 upon r square del by del r square del v by del r equal to 0. This also means that, okay, r square को right side में multiply भी किया, so this means that del by del r of r square del v by del r equal to 0. Now derivative of a particular term is 0. Derivative of a term is 0. That means that particular term should be constant. So what term? R square del v by del r equal to some constant, suppose k. Let me start from here. R square del v by del r is equal to some constant k. So what is the value of del v by del r? It is equal to k by r square, and if that is del v by del r, what is going to be v? Okay, what is going to be v? Now you start integrating it. Okay, and then you will get 1 upon r square ka integral. 1 upon r square ka integral is minus 1 by r plus constant of integral. So suppose that constant of integral is c. So this is what is the potential, which is a function of r. As you are able to see, the potential as a function of r is minus k by r plus c. Okay, but what is k? What is c? What is k? What is c? How to obtain the value of k, c? That is why the potentials on two different radii, that is two different spheres, has been mentioned to you. Okay, so now we are going to use that at the r, which is equal to 3 centimeter. Okay, the potential is 100 volts. So 100 is equal to minus k by 3. Okay, r is in centimeter, so 10 power minus 2 भी ले लेते हैं, plus c. Okay, so 100 is equal to ये हो जाएगा minus 100k by 3 plus c. That is one of the equation. Okay, now I will use the next condition, that is at r equal to the 5 centimeter, potential is minus 100 volts mentioned. Minus 100 is equal to minus k by 5 into 10 power minus 2 plus c, or minus 100 is equal to, this becomes minus 100k by 5 plus c. Okay, if I take both these equations together, first equation says that 100 is equal to minus 100 by 3k plus c. Second equation says that minus 100 is equal to minus 100 by 5, that is nothing but 20. So minus 20k plus c, and we can easily subtract these two. Okay, let me just subtract these two. Okay, so when you do 1 minus 2 subtraction, 100 minus minus 100, left side will be 200, right side c will get cancelled. Okay, so if you cancel c, you are left with how much? Minus 100 by 3 minus minus plus 20 times k. यहाँ से आ जाएगा k का value. So this is 60. So minus 40 by 3k. Okay, is 200. So the value of k is minus 3 by 40 into 200. That is minus 15. 200 by 40 cancelled. Correct. K is minus 15. Now if k is minus 15, what is going to be the value for c then? Okay, what is going to be the value for c? Let me use the simple equation. Suppose anyone, first equation कोई भी use कर ले, दोनों ही simple होगा. 100 is equal to minus 100 by 3 into k, which is minus 15 plus c. Okay, so 100 is equal to ये हुआ 500 plus c, and c is minus 400. C is then minus 400. Okay, so now what is the potential function? K and c दोनों आ गया है. Potential was equal to minus of k by r plus c. That means the potential as a function of r is minus k by r. Minus k will become 15. That is 15 by r plus c, and c is minus 400. So that is what is the potential function. 15 by r minus 400. 15 by r minus 400. 15 by r minus 400. Okay, that is option number A. Only option number A matches. And then they are asking, that is automatically solved. What is the value of r at which potential equal to 0? What is the value of r at which potential equal to 0? Okay, so V is equal to 0 at 15 by r minus 400. Okay, so you have 15 by R equal to 400, and the value of R is 15 by 400, and 15 by 4 is 3.75. 10 power minus 2 will be centimeter, so 3.75 centimeter. But that is already in the option number A, na? That you need not calculate. Okay, yeah, meters mein likha hai to 0.0375, that's okay. Okay, so option number A overall matches. Option number A overall matches. Correct. Chalo. Done. Okay. So guys, yesterday's PDF I think I could not share, just skipped out of mind. So don't worry, I will share you the yesterday's and today's PDF both. Those who were waiting for the yesterday's PDF also, that was the questions on electric field and Coulomb's law. Today we have discussed some questions on electric potential. Okay, but the PDF, as you know, as a rule will be password protected, and the password is going to be, for the PDF, let's keep today a simple password, that is potential. Anything at random, potential. Everything in small. This is going to be the password for the PDF. The PDF will be there in my Telegram group. Okay, you can open the PDF and access it using this password, POTENTIAL, potential. Okay, that's it guys. See you tomorrow with the next session, that is the questions on Biot-Savart law. The important questions on the Biot-Savart law. Okay, bye bye. Thank you. Stay safe and take care of yourself.